Welcome to This Explainer. Let's dive straight in because today we are tackling something absolutely massive: mind versus cosmos. Think about it. The universe is overwhelmingly huge, ancient, and honestly pretty violent. And then there's us, right? Confined to this tiny, fragile rock. Yet somehow, against all odds, our minds can actually grasp the workings of the cosmos. So how exactly do we do that? Let's find out. When you or I just go out and look up at the night sky, we're really only seeing a few thousand glowing dots, and maybe that hazy little streak of the Milky Way. But consider something like the Coma Cluster. When astronomers look deep into the sky, they find that what look like little fuzzy blobs aren't individual stars at all. Literally, each one of those blobs is an entire galaxy, crammed with billions of stars, all bound together by gravity across tens of thousands of light years. Honestly, it's almost impossible for the human brain to truly make room for the sheer scale of that reality. And the scale isn't just large, it's incredibly alien. Out there in the imaginably desolate voids between those distant galaxies, the background temperature of the universe sits at 2.7 Kelvin. Now, to put that into perspective, that is just 2.7 degrees above absolute zero. We are talking freezing cold. Literally cold enough to freeze every known substance in existence except for helium. When you contrast that pitch-black, empty vacuum with our familiar environment, it really highlights just how uniquely warm, dense, and weird our Earth actually is in the grand cosmic scheme of things. Which forces us to ask a pretty profound question. How do we, stranded here on our tiny, weird little rock, know absolutely anything about these invisible, distant, and violent phenomena? I mean, no human has ever visited the core of a star, let alone traveled millions of light years out to the Coma Cluster, right? We haven't been around for billions of years to witness the Big Bang. We're isolated by distances we can't even fathom. And yet, we can confidently describe the nuclear transmutation happening inside distant supernovae. How did we get that knowledge? Well, historically, we relied on a philosophical doctrine called empiricism to answer that. Empiricism basically assumed that the universe just passively writes knowledge into our eyes. It treated our minds like blank slates. The whole idea was that if we just observe nature enough times, we'll mechanically derive our theories straight from those sensory experiences. You watch the sun rise repeatedly, and boom, you simply extrapolate that it will always rise. Sounds like common sense, doesn't it? In fact, this idea of empiricism was so culturally dominant that even our most brilliant fictional minds totally fell for it. Arthur Conan Doyle actually had his legendary detective Sherlock Holmes declare that theorizing without data is a capital mistake. The underlying assumption was always the same: gather the raw facts first and let those facts dictate your theory. Basically, suppress your imagination until nature explicitly tells you what's true. But what if Holmes was completely 100% wrong? What if data is actually impossible to understand without creatively guessing and theorizing first? You see, the universe doesn't just beam explanations into our brains. It only gives us little dots of light. To interpret those dots in the sky as million-kilometer spheres of transmuting gas, somebody first had to creatively invent the whole concept of a star. You just can't extract that concept purely from the experience of seeing a dot. We have to guess. Now, humans have been guessing for millennia, for sure. Let's compare a really ancient, bad explanation for the seasons, the Persephone myth, with our modern scientific axis tilt theory. In the myth, winter happens because the goddess Demeter is sad that her daughter Persephone is trapped in the underworld because she ate some magic seeds. Okay, sure, it's an explanation, but notice how incredibly easy it is to vary the details. You could totally swap out Demeter for the Norse god Frey, or say Persephone escaped instead of being trapped, and the myth would still explain winter just fine. It's a bad explanation because its core components are just completely arbitrary. But then, look at the axis tilt theory. What's really fascinating here is that every single geometric detail plays a strict functional role. You cannot alter it without breaking the entire concept. If you change the angle of the tilt, or you change the shape of the Earth, the whole theory completely stops explaining the seasons. You can't just casually swap out the sun for the moon, because the geometry of radiant heat hitting a spinning sphere is rigidly essentially connected to the reality of what's happening. So, the crucial takeaway here is that humanity's true superpower is the quest for good explanations. A good explanation isn't just a story, it's a theory that is incredibly hard to vary without ruining its ability to account for the phenomenon. The ancient Greeks didn't fail to understand the cosmos because they lacked data. They failed because they accepted easily variable myths. The scientific revolution only really took off because we finally started seeking explanations where every single detail is strictly necessary and incredibly hard to vary. Now, you might be wondering, why do we need these good explanations so desperately? Well, honestly, because our senses are notoriously fallible. All observations are theory-laden. When you look at the sky, you aren't experiencing it as it actually is. Your brain is just interpreting electrical signals and constructing a really convincing local illusion. For thousands of years, humans looked up and clearly saw that the stars were fixed on this rotating celestial sphere and that the Earth was completely dead still beneath our feet. Our senses trap us in these local illusions, which means we absolutely have to use good explanations to actively correct what our eyes are telling us. This whole idea becomes even clearer when we look at modern scientific instruments. Take the discovery of pulsars, these incredibly dense, rapidly spinning stars out in deep space. When the astronomer Jocelyn Bell discovered them, she didn't look through a glass lens and actually see a spinning star. What she saw was a shaky, jittery line of ink on a piece of paper. That's it, ink on paper. And this brilliantly illustrates the totally bizarre reality of scientific observation. Physically, to learn about the universe, human beings go out and dig up iron ore and sand from the dirt. We rearrange all that stuff into complex screens and giant radio telescopes. Then we sit in a room and stare at local pixels, or ink on a page. We're just looking at human artifacts that are close enough to touch. Yet, thanks to layers and layers of robust scientific theory, we're able to look at those glowing pixels and effectively see a star that is light years away. Our instruments don't hand us raw reality, they only bring us closer to it through the theories that actually power them. And because these good explanations are so robust and so hard to vary, they do something genuinely magical. They possess an autonomous domain of applicability. Basically, they have infinite reach. When you invent the axis tilt theory just to figure out why the sun's elevation changes in your backyard, it automatically reaches out and explains why the seasons are completely opposite in the southern hemisphere. It explains the midnight sun at the poles. It even reaches out to explain the weather on planets in other solar systems that we haven't even discovered yet. Good explanations reach all the way from our finite local brains straight to the edges of the cosmos. Now, this idea of infinite reach directly challenges a very popular modern worldview that you've probably heard of, the principle of mediocrity. It was popularized by the brilliant Stephen Hawking, who once said that humanity is merely insignificant chemical scum on the surface of a typical planet. The general vibe is that the universe is so vastly huge, and we are so tiny, that we are ultimately cosmically meaningless. But based on what we're learning today, we must absolutely refute that idea. Think about it for a second. A dead star exploding as a supernova can blindly transmute base metals into gold. Sure, but only an intelligent being can actually understand why that happens. If you find a good explanation anywhere in the universe, an intelligent being must exist there to have created it. The physical matter of our brains might literally just be chemical scum, but our capacity to generate explanations that map the entire universe, that makes us uniquely significant in the cosmic scheme of things. Which brings us to this final, absolutely thrilling thought to wrap up our explainer today. If we are entities of such profound cosmic significance that our small, localized minds can accurately map the most distant, violent phenomena in the universe using nothing but good explanations, what limits can we possibly place on our future? If our capacity to understand is truly the beginning of infinity, what wonders are we going to explain next? Think on that for a bit, and as always, keep seeking those good explanations.